Hey everyone, welcome to Duodecimal Division. My name's Eric Larson, and in this video we're going to go over one more time the difference between base 10 and base 12 math. The reason I'm doing this or going over it again is because I feel this is the most important first step for anyone to really understand base 12 math, is to understand the difference between base 10 and base 12. Right now there is a prevailing attitude that there is no real difference between base 10 and base 12. I've noticed that in my videos where I just start off and say, okay, I'm going to talk about base 12 math, very quickly everybody just bails out on the video because, again, I think the overall attitude is that there is no difference. But there is a difference. It's significant, and ultimately it relates to the base 12 version of pi. The base 10 version of pi, we're talking about the geometry of the circle. The base 12 version of pi has different qualities than the base 10 version. So that's where we're going to end up. But before we get there, let's just talk about what's the difference between base 10 and base 12 with relation to the circle. So you can see here we're dividing up the circle, and I've counted around all the sections, and I've done it in base 12. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we have these two extra symbols, and then a 10, and then it continues on to 20. And so if we were in base 10, this would be 12 and then 24. So at this point, if we just stop there and look at that and don't really go any farther, look any deeper, I can see why you might think, well, what difference does it make? All those points are the same. They exist whether we say it's 10 or 12 or 20 or 24. It doesn't really make any difference because it's all the same points. So we can work with that. But the real difference comes when we divide up the 1 and we start looking at the distances of these points and using the decimal system with regard to dividing up the circle. If you think about it, pi is a long decimal number, right? We have 3, then a decimal place, and then a whole bunch of numbers that are divisions of tenths. We're dividing into tenths. So what happens when we approach these division sections, base 10 or base 12, these different little sections here? Well, let's just count. In base 10, you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So if we start here, we're counting. We know that the formula, I should say first, we know the formula for pi, for calculating pi in relation to the circumference of the circle is 2 times pi times the radius. And actually, I should get my clear board here just to write that on the board so it's very obvious. Okay, so here we go. 2 times pi times the radius, that equals, let's say C is the circumference. Okay, so now we're going to just count. Here we start here. We're going around. We're going to say this circle here has the radius. We're going to give that circle the radius of 1. So here we have 0.1, 0.2, 0.3. We're just going to divide. No, obviously there's sections of pi. So 0.1, 0.2, 0.3, 0.4, 5, 6, 7, 8, 9. Now here, what about this? Okay, so in base 10, now we're at 1 right there, but we know that's not 1. If the circumference is 2 times pi times the radius, the whole circle is 2 pi, so half the circle is going to be the length of 1 pi. But now we got our 1 in base 10 is there if we're using these size sections, these size units. So in base 10, we can't say that that's 0.1 pi. 0.1 pi in base 10 is actually a bigger unit. You're going to have a bigger piece so that it's like 1, 2, 3, 4, and halfway is going to be 0.5. Half of 1 is 0.5 in base 10, so we have bigger size units. But in base 12, we've got 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Then we've got 2 extra numbers. Here I've used the symbols called dec and L, but it could just as easily be A and B. So we go point A, point B, and then 1. So when we're in base 12 and we're dividing this 1 up into decimal places, that's exactly where those places line up. They line up on these lines perfectly. So that's the beginning of dividing the circle up from a base 12 perspective. We can use this pattern. It works perfectly. This is why when you see the unit circle, when they refer to the 30-degree line here, they have to refer to that as pi as a fraction. They say, well, okay, that's like, 1, 2, 3, 4, 5, 6 of those. So pi divided by 6 is the 30-degree angle. And they go here, well, that section, it's 1, 2, 3, 4. So this 45 is pi divided by 4. And here we have, 4 sections. So 4, 8. Again, we're kind of working in 12s, but we have to keep it in fractions. We say this is pi divided by 3. So that's how we approach those lines, because those are obviously very important angles. The 30-degree angle is called the special right triangle. This triangle that's formed here, that's 45, the 30-degree. Those are very foundational angles that are used throughout geometry and physics, to figure out the workings of the universe. What I'm saying is the base 12 version of pi lines up with these very important angles and degree lines in a way that the base 10 version doesn't. Again, looking at the fraction, or the question 1 divided by 3. Well, here again, if we, instead of saying pi, we just say 1, because we know it's going to be 1 pi, so there's a relationship there. 1 divided by 3, 1/3 in base 10 is 0.333, because what happens, remember, you have a bigger sized unit, so you go 1, 2, 3. We don't quite reach that line, so we have to divide. We divide up our 1 into tenths, and then we add 3 more of those, and we get a little bit closer. But this basically repeats forever. So in actual fact, we never actually even reach that line. We just get smaller and smaller and smaller and smaller, and it goes on forever. Yet 1 divided by 3 in base 12, well, we just saw it's 0.4, and that's it. 1, 2, 3, 4, 0.4. We land right on that point in the very first iteration of the equation, and that's done. So again, there's a difference there. Those numbers, those answers have a different quality. There's a, 1 stops, 1 repeats forever. So let's just think about that. Maybe is it possible that the base 12 version of pi, when compared to the base 10 version of pi, also has different qualities? Is there different characteristics? How do we know? What is the formula for pi in base 12? How do you calculate the base 12 version of pi? Well, you start with this formula. You can do it using geometry. This is geometry, very simple, very basic. It's easy to do this pattern, and that's the beginning of the pattern that you use to calculate the base 12 version of pi. Currently, there is no way to divide up the circle using base 10 geometry. So what we're going to do now in the next video, I'm going to introduce you to the base 12 version of the Cartesian plane, and it's the same thing. The distance between the 0 and the 1 is divided into 12ths, just like this section of circle is divided into 12ths, not tenths. So we're working with different sized units, just like here, we're working with different sized units when we divide up the 1. It's the dividing of the 1 into 12ths as opposed to tenths, so we have a different sized unit, and then we approach the circle, the points line up differently. That's the real difference between base 10 and base 12. All right, thanks for watching. Hope to see you in the next video.